case. I think instead of talking very broadly on different aspects of legality, ethics, and responsible AI, what I try to do here is that I try to focus it on deepfakes so that you can actually relate it back to the works that we have been discussing so far. And then once you relate it, you can also take it to the next level and then try to apply it in your own field. So any system that we're going to develop, it has to respect the principles of privacy, ethics, and legal framework, right? That we all agree. Now I'll take here an example of what has happened. And before I do that, I just introduce you the small history of generative AI and then where we are standing, and then try to connect everything that we have learned so far. So the first thing, as we were discussing, 2014, there was this renaissance of ImageNet or DL, which led to what is called as the ImageNet. And in the same year, 2014, the seminal work on generative adversarial networks came out, which is from Goodfellow et al. And that's the architecture, right? That's something that we started with. We saw that there was this discriminator generator, and then we use it for various use cases. Now, around the same time, this Defense Research Agency in US, they launched this program called as Media Forensics, which kind of brought the attention of the academic community and also the industry community to start looking into the side effects of these technologies, right? So what they wanted to authenticate at that point was to see if the image is actually original or if it's been manipulated by some method, okay? And then following that, as when the program was launched in 2016, came this approach which is called as face-to-face. And here you see that a person sitting outside can transfer the target, can transfer the expressions and the face itself to the person in the target. So what would that mean? That would mean that now I could put my words into the mouth of Pranav, right? So that means that you are now in a position to make use of this technology for any kind of use, be it good or be it bad, right? So then comes the first aspect of ethical use, right? So how do we take care of this? And then came in 2017, not more than a year later, face-to-face came. So there was the cycle gun, which is again everything that we have learned so far. We see the same architecture there: encoder, decoder, along with a discriminator. Then you have a new network, right? So here I could transfer the style. So what would this mean? This means that now I can transfer my image to be sitting as a rich man in a helicopter, right? So I can transfer the style. Now I could use it for many malicious uses. And then in 2018 came this another work which is called as Synthesizing Obama, which was released around 2018. And there you see that the image quality or the video quality that we were generating was certainly of very high quality. Along with the high quality video, what we were also doing is we were transferring the text to speech. So that would mean now I could write a speech for, let's say, the Prime Minister of India, and the broadcasted speech can be completely manipulated by my content, my speech, right? Which also leads to this problem, right? Which means that I could spread the hate speech, I could spread the propaganda, right? So the implications become broader and broader. And then along the same time, now if you think about all these things are very difficult to achieve, to create, you can go back to this website, which was, I think, published in 2018. They released this open source repository, and now suddenly everybody could create these deepfakes, create the new content, synthetic content, without even having any fundamental knowledge of how the system works. All it does, takes an image, creates a new output, and gives it to you. So this means now we were in the position to create a data set of millions of images. And the very first data set that was released was from TU Munich, which is called as Face Forensics dataset, released approximately in 2018 in March. So now all these things were happening on one side of the story where the deepfakes was continuously getting improved because of generative adversarial networks and the advancements in that. And then now if you look on the other side, so the very first paper on morphing attack was released by Matteo Ferrara and Annalisa Franco and Davide Maltoni from University of Bologna, a landmark paper which was called as the Magic Passport, which showed that it's not only the generative adversarial networks you should be worried about, but it's also the classical computer vision approaches that can create very strong synthetic images which can be misused. And then at the same time, if you go back in the timeline, you can also identify that there are being papers which talk about adversarial attacks somewhere between 2014 and 2016, right? So this was where we talk about how can I flip the image from being Kiran to Pranav just by introducing some small amount of noise, right? So this is what we call as the adversarial attacks. Those surface around that time. And then we had two EU projects which was studying, okay, what is the impact in real life. So everything is nice in the research side, but what would happen if I'm putting it back to the research, putting it back to the real world, right? So to study that, we did this project which was on studying the vulnerability of all the face recognition systems. And then following that came this project in 2020, which I've been discussing in different contexts. And here the idea was that any image that you create, how much is it strong in attacking the face recognition system, and how it can create defense mechanisms. Okay, and then just to recap this one, right? So in this case, you see that everybody were very curious about creating new content, creating highly realistic content. But what was happening on the other side is that it was able to attack all the face recognition system on the other side. Now, everything that was designed for something like, let's say, entertainment was or can be misused, right? Which creates a bigger problem. And then what is happening on the other side, right? All these tools are wonderful, but if you look at the whole landscape of this research, landscape of this area, you start seeing there are some concerns. So the very first concern is the gender, right? So we have this male and female distribution in every single data set. Now, what was happening with the use of this technology was that 9 dedicated deepfake pornography websites were making use of these kind of images, which is a significant number, right? Now, I'm talking about these numbers. I think it's from probably 2021 or so. And this is not really good. If 8 of 10 pornography websites use, that means that we don't have control of our own data anymore. For everything that we know, our images can be misused. Right? So there comes the first idea of having the ethical use of this AI, generative AI specifically. And then let's talk about the other part, right? There is this concerns about the bias. What does the concern about bias mean? The system is trying to negatively identify me or negatively to give a negative performance just because my skin color is darker, right? Which is something that we don't want, right? We want the systems to treat every single individual equally. So now you can also extrapolate the argument. What happens if the case of not just the skin color? What happens if the person has some physical deficiency, right? If the person does not have the visual power as we have, maybe some people are partially blind, right? So all these small factors, this chunk of different demographic groups are now coming into the picture here. So are we treating everybody equally in one side? On the other side, we are talking about this. Is there any particular gender that is being extensively misused? Right? I mean, it's a bit of an unfair situation where most of these are revolving around these minority groups, right? Whatever the context that is. So now, what we should do, I'm going to talk a bit about this aspect in the bias. Of course, you can now go back to this and then connect it to different legal frameworks. If I talk about the EU AI Act, it might not be very relevant for you because India has its own regulations, right? So you'll have to look up for the regulations within Indian Constitution for the usage of AI. But whatever I'm giving is the base ideas that you can apply in the legal framework. Okay, so if you look at the literature, so the literature, according to the dictionary, there are at least the bias is defined as a strong feeling in favor of or against one group of people, or one side in an argument, often not based on fair judgment, right? So if today, if I'm going to Professor Neeta Nain and then tell that, okay, I have some idea and my pal is also there, and then she suddenly supports me without factual evidence, that's a bias, right? Okay. So, and the same thing can happen with algorithms as well. So it might give you some answers without having objective measures. I'll explain you how this comes in the picture of deepfake in a short while. But now you understand the idea that we should take care of these aspects, right? Okay, so when it comes to there is a wide taxonomy of this bias. I think, I don't know, 39 or 32 biases are defined, and more than that, beyond that, some of them are still applicable, right? I can't cover all of them, but what I'm going to talk in chunks, in bits and pieces, is about three aspects. One is this data set, which is where we talk about sample bias and the exclusion bias, and the machine one, where we are talking about the algorithm bias and the anchoring bias. And the third one is at the decision level, which is about prejudice, measurement bias, confirmation bias, and so on. Right. So all of these things now come into the picture because we are talking about something that is here, right? So what we want is that we want a nice data set, and from the nice data set, we'll be able to create nice algorithms, and from these nice algorithms, we should be able to reach systems which are fair, which are ethically bound, and also responsibly used. So what is the problem? If we have a nice theory here, we know that, okay, all these data sets are available. So what is the problem? The problem is that many of these data sets do not have right annotations, right? So what am I talking about? When I'm saying right annotations, somebody has to sit and annotate telling that, okay, this is a white woman with blonde hair, with glasses, coming from this region, and so on. And the same applies even in the case of medical images, right? You might want to sit and annotate, okay, this is a COVID image. These are the areas which represent the COVID. And the other one is which region, which device, and so on. Now, doing this is a very challenging problem, right? I mean, no doctors will have time to do this. If they have to save a patient and then annotate the data, they probably would always choose to save a patient than sitting and annotating data, which is not different from even our field, right? If you are given a task of creating a nice algorithm, you probably would be more interested in doing that rather than sitting and annotating data, because it's very boring, it's tedious, right? So that means also whatever you are measuring today, they're all relative performances. So without having the actual ground truth, without having the baseline and benchmarks, we are just simply reporting the performances. And then there is this other problem, right? Because of the inherent mechanisms of missing annotations and relative performance analysis, the metrics that we are using are not really the actual metrics. For instance, when we are measuring the equal error rate in the biometric systems, or the error rate in general, so we are considering the closed set situations, right? So we know the training set, we know the testing set. So what should we be measuring? We should be measuring the open set performances, which means what happens when the machine learning system has not seen some samples? How does that behave? Okay, so I kind of motivated you there. So what I'll talk about here is that we will see that in next couple of slides, you can see that how the sample bias comes into picture, how the exclusion bias comes into picture. Let's take, for example, um, a simple challenge, which was run by the defect detection challenge here. And in this case, despite the number of data sets growing, the proportion of subgroup data sets are always not balanced, right? So there is an explosion of data sets here. You see that there was data set number 1, data set number 2, 3, 4, and you see that in the first generation plus 1 data set with how many subgroups? I think it's, maybe I can zoom it a bit. Now you see that, right? The total number of frames are increasing, the content is increasing, but they are not really considering all the population from India, China, US, Germany, and so on, right? So you understand that there is the abundance of data set, but not demographically balanced. So what should we do, or what is the first thing that we should do if we want to address the bias? We want to understand what each factor is playing a role about. Is it actually all the male people that are being misidentified, or is it all the female people that are being misidentified? Or let's say, in the case of this deepfake, are all the female people being labeled as deepfake images? Right? So the very first thing that we want to do is that we want to annotate this data set. So what can be done in this case is there is this deepfake annotation, not or let's say not deepfake, but image annotation toolkit, where if you pass the image through that, it gives you approximately 34 non-demographic attributes, such as the skin, the hair color, the face geometry, mouth, nose, and so on. And then in addition to that, it also gives you some demographic details, which tells, is it a male, is it a female, young, old, is it white, black, Asian, and so on. So once you have this kind of annotations, now you can use it for studying the performance, right? Now I can, given a particular algorithm, is it performing equally well for male and equally well for female? So what can I do? I have this labeling tool. I select 100 images of male, 100 images of female, then I can start understanding how the algorithm is performing, irrespective of the gender. And again, this tool is publicly available, so if you are interested in that, you can use that. Again, here the idea is that the approach works very easily, where it looks at the predictions, and then it looks at what is the reliability score of that, and then there is a particular threshold that is used to say that, okay, this is male, this is young, and this person is coming from, I don't know, from Asia. Okay, and then there is also this other problem, right? I can trust the machine. There is a nice algorithm, but how much can I trust it? Is the machine perceiving the person to be Asian as I would perceive, as a human would perceive? So that means this has to be validated, right, with some human experts. And there is a problem of bias again. If I'm going to put three people who are coming from, let's say, from China, probably they will not be able to separate out all the population from India. And it's a problem vice versa, right, for us? If we are all sitting in a room and trying to annotate the people from Asia, maybe we will confuse people from China from people from another country. Right? So what am I trying to say here is that there is the problem of bias. It also stems from very ground level. So the people that are trying to annotate this have to also be very well balanced. So they should be represented equally from all different demographic groups. But in reality, that is a problem, right? I can't really get all 10 annotators from all different countries to just look at all the images. So we have to deal with this in real life to some extent. Okay, so what did we do in that case to start with? We wanted to annotate all the data sets and then try to see what exactly happens. And now you see that for some of the annotations, the database does not represent that features. So if I want to study how is that system impacting people who are in middle age, people who are in young age, I can't do that because this data set does not have that annotations, right? So there are certain limitations which tell that for certain kind of approaches, you can't study all the factors. So that means you have to compensate for these kind of biases later on. And now then there is also this, again, this is just to show the timeline changes. You see that the first data set has so many annotations missing. Second data set is slightly better. At least it's now introducing some other features here. The young and the old population is somehow represented. And if you go even further, the newer database that also has more representations. It has all kind of attributes. So if I have to study something that is more balanced, then probably I should look at the right kind of the database, in which case this might be a suitable candidate, right? Because it kind of represents all demographics, all features, everything that I would want to study. And then came this another data set. Unfortunately, this data set did not, it was one of the larger data sets, right? The Deeper Forensics 1.0. It's very challenging data set, by the way. But the point is that it does not represent all single attributes that we are interested in. So now, if I want to study male and female, maybe all of these data sets are useful. But if I want to study something regarding the, let's say, wearing the lipstick, this data set is not very useful, right? So always make choices when you are, make some choices based on all these factors. Okay, good. Again, just to give you an idea, if you are interested in using the annotation toolkit, it's also available publicly here. You can go to that GitHub link and then download it. So we have also released the dataset which is annotated. Here in this dataset, we release annotations for all the major datasets that are used in deepfake, along with these annotations here. Okay, I'll not talk about this one, but now I'll talk about the aspects of correlations and how it is related to this bias and ethical use. Okay, look at this particular image now. So if you look at this image, so the very first thing that we wanted to analyze was that how much is this correlation between different type of attributes. What do I mean by that? So if the person is black, what is the correlation for that to be shiny skin, right? So these are two independent factors, and how much are they correlated? Are they positively correlated or are they negatively correlated? For instance, you also see that there is another aspect, right? Take the first column, and then you're looking at a person who's dark in skin color, and then you see that suddenly it has a negative correlation that the mouth is closed. Is it actually true? I mean, just because the person is dark doesn't mean that he has his mouth open all the time, right? Unfortunately, there is some kind of correlation factors that unravel the patterns, how they are interconnected in this data set. Take another example here, right? So now if you look at this one, so there is a high chance that if a person has a mustache, then he also has a goatee. Two different kind of facial hairstyle, right? But then what is also interesting is that you also see there is a negative correlation with no beard. That somehow makes sense. But then you also see some amount of correlation with wearing lipstick, right? So you see that there are some inherent biases which are always present in your data set, right? So you see the correlation, very strong correlation here, mustache with body, very high relation here, and then it also tells that the likelihood of having a mustache is very high with having a square face. And these are nothing but it's not designed by from the scratch up, right? It's something that we observe in the data sets. So I'll just highlight one more part here, just to give you an idea that whatever you are trying to measure in your algorithms, you should also take care of these kind of factors. Okay, so now I spoke a bit about this data set bias, right? So there is an inherent bias at the data set level. And then let's talk a bit about algorithm bias. So when we are talking about the algorithm bias, if you take any of these systems, any existing system, right? And then you try to say, okay, let me just try to, here is the example of Disney projection. In the Disney projection, you see that all the algorithms are not treating everybody equally. So whether it's algorithm A or B, you would always have some kind of biases, or the performance will vary. In which case, if you take a look at all these existing datasets, such as CelebDF, DFT, FF+, and so on, all of them have different methods, and then comes the problem, right? There is no gold standard method here. For instance, if you have to, there is no standardized method, as in the case, let's say if you want to tell that the quality of the petrol is very good, so then there is a body which goes and inspects every single petrol station, and then they tell that, okay, the quality here is 90, the quality here is 50, because they have one method which fits everything. But in this case, there is no standard method. There is no golden state of the art, which would mean that I might like method 1, which is based on efficient net, and Pranav might say, oh, no, 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 I like exception, right? So there is individual preferences for algorithms. So what is that we are reporting in all these cases? We are reporting only the error rates or the accuracy. But what we want is we want the balanced accuracy, right? So accounting for the factor that, okay, how many females were there in this data set? How many males were in this data set? So given that, if the error rate is equally distributed or it's skewed for male versus the female. And what we do in this case is that, again, no magic happening here. The only simple calibration is that, okay, I have this annotation, it's male or female, and I look at the error rate for this person when this person is present in the data set, and I look at the error rate when this person is not present in the data set as a subgroup, right? The male subgroup and the female subgroup. If they're present, what is the error rate? If they're not present, what is the error rate? And just take a simple difference between them. Then you are trying to say that now it's a balanced error rate that I'm reporting, right? So what I'm trying to do, I'm trying to once include, once exclude, and measure the error rates. Gives an idea? So now I'm trying to mitigate the performance that I'm saying at the performance level. So first I gave you the example of dataset bias. Now I'm showing you the performance bias here. Okay, let's take a simple example here. So why am I talking about this biases in the context of ethics? So if I'm creating an algorithm and the algorithm is giving me an error rate, let's say X%, and this X% is varying depending on what kind of attributes are there, then it's a problem, right? For instance, here, if you look at this image very closely, it says that the error rate, the relative performance, decreases when you have your mouth closed. It decreases when you have the lips, which are quite big. Right? However, the error rate also increases, relative error rate here, when you have eyeglasses. When you have, let's say, if you're smiling. So the idea here is that the performance metric that you're using should also account for this one, right? So now what we are suggesting is that we should not just use the relative performance, we should also use the corrected relative performance, right? So try to measure the correlation between them. Okay, so now here you can see that the goal would be that we should be ideally lying in this radius. So it should be very close to this one. The error rate for CRP and this one should not change. If it is changing, it indicates that there is a bias in the algorithm. Here's an idea. Maybe this is a bit abstract, and I don't expect you to understand every single small details, right? But what I'm trying to convey here is that remember to analyze all these different factors when you're presenting your algorithm for understanding what the bias is. Okay, and again, this is not the only method, right? There are a number of methods where you can use for measuring such kind of correlation, such kind of differences. I'm taking one example here. Anybody that's not following this one? At least at the abstract level, you are able to follow the idea? Yeah? Good. Okay. So let's say, what does this mean in reality, right? So I have this, you remember we made this matrix of true positive, true negative, false positive, false negative. In this case, if you look at the real images, these are two real images, and it's credited as real. Good. So that's what we expect. And now, there is real images, but they are credited as fake. And here, look at the some kind of inherent bias, right? So the two male people are first of all detected as fake, and on top of that, there is a pose variance. So what is the algorithm measuring? Is it measuring the actual performance, or is it actual image as real or fake, or is it looking at the pose of the face? And then comes the second aspect, right? So take the fake examples there. Now, the fake examples are being predicted as fake, makes sense. In this case, I see some obvious artifacts here, right? In the chin area, in the cheek area. However, for the other side, you suddenly see that those two images, which are supposed to be fake, they are classified as real. Now, the problem again is that Now, here I've taken some random examples. Right? In this case, it's just males, and this case there are two images, both male and female. So we want to isolate all these factors. This is what is called as the disentanglement, right? Uh, so the next part is about bias in the deepfake detection. Now, one of the thing is that it could be due to different factors. I can't really pinpoint unless I create the data set in exact same conditions. I'll not be able to say this exactly is what happening, right? So which would mean that if I want to study what is the impact of lighting in this room, so I would have to ask you all to wear the same kind of the clothes, exactly same color, so that the reflectance is uniform, which is impossible, right, in real world. So we have to deal with it in different ways. So, and where do they come from? They come from this imbalanced training data. We have seen from the day one that data is not equally representing both male and female. It's not equally representing people from Asia and people from Africa. So there are these certain factors. And then I also told you about this, the networks that we are using. Whatever is your preferred network might not be the same network somebody else uses. And then what kind of training process has been applied? Remember, I spoke about this batch normalization in the case of few network training. I told that you should always make sure that every mini batch is representing all different kind of samples, and this is one of the reasons, right? If you're not doing that, then the factors will be leading to some biased performance. So anyway, all these things cannot be really well pinpointed, but all it suggests is that it needs further and deeper investigation. So those of you who might be interested, you can take this direction, then go deeper, try to create controlled data sets, and then try to analyze all this performance. Okay, and then what happens in the case of images that are being fake and real? Is the bias equally for fake images and also for the real images? Or in the case of generative networks, we can talk about the image that is generated through GAN networks, through diffusion networks, and so on, as compared to the images that are real. So here you see another error, right? So if you look at this particular aspect, you see um, the detection model somehow assumes the presence of certain attributes as an indicator of deepfake, right? This says that if I have, in this case, for all the fake data, if the person has double chin, it assumes that it's a fake image, right? It's again, it could be a situation where a person has health issues, and he is in certain situation, right? Now we are telling that image to be exactly deepfake just because that attribute is present, which is unfortunate. And now on the other side, right, you also see that if the person is black, the likelihood of that getting classified as fake is also very high, right? And that is here. You see this cluster. So we should be ideally in this one where the error does not change. But you see that it increases for this sector, and it also increases over that sector, and decreases over this sector. Gives an idea? Okay. So just focus on the central part where I'm pointing. So what does this mean? So in this case, for the fake images, now you see that a real image which is coming from a black person there, it's being detected as black, as real, which is good. But then a real image that is of another person from a different ethnicity is now identified as fake, right? So this happens for the fake prediction. Now what happens for the in the other case, right? Now if you want to do it with different data set, in the different data set, all of them are from the same ethnicity. Despite all of them coming from the same ethnicity, there is a unexpected behavior of this algorithm, right? So it gives an idea. So these algorithms are biased, and also there is a bias in the data set itself. Okay, so now what does this mean? This means that we investigate the attributes that we have investigated. They kind of indicate varying detection performance for both real images and also for the fake images. So we can't really pinpoint what is coming from where. And irrespective of method, this is the pattern that we are seeing, right? Whether I use exception or whether I use something else, it's still the same. And then what is questionable is that now you can question the whole work, right, that we have done. So you can say that the assumption of a certain attribute is a strong indicator, and we say this kind of observation based on what you have seen in the empirical evaluation, and that is still questionable, right? Questionable because what is the guarantee that my detector or my attribute annotator is 100% correct? And that would lead to this kind of problem, right? So if there is problem there, and then it will eventually lead to further biases in the other part. And then is the some findings that we had is that of course the databases have strong correlating attribute pairs. I showed you that, okay, if a square face is there, then it's most likely that he has a mustache, which is actually not true, right? So we know it from real world. And then the deepfake models also behave very differentially for different kind of demographics. So it treats male differently than the female. It treats people of younger age differently than the old age. And this is also cascaded to the next part, where you see that both real real images and also the fake images are getting misclassified very often. And somehow everything that we are looking at this one, it's not really telling that what is real image, what is deepfake image. It's rather making the decision, and these decisions are directly connected to the attributes, which is unfortunate, right? And if you go a bit deeper and then start looking at this, okay, maybe I should have at this particular model, we took that work a bit further, and then we tried to analyze what is actually causing the performance there. Is it the image or is it something else? So then what we did was we stripped off all the images from the network. We said, now let's try to just look at the features. That is nothing but annotation, right? Now instead of using image, I just say, okay, this image is from a female. This person has a, let's say, big nose. This person is smiling, and I put all these parameters, all these attributes, and just by learning these attributes, I can still achieve a very good performance. Now, if you look at this particular aspect here, right? Here in this case, you see that the state-of-the-art methods that are actually using images, they provide you a result of around 99%. And without using images, you see that using random forest and support vector machine, I can get a performance of 69% and 70%, almost close to 70%. So what does this say? It says that I can create classifiers without using the images. Doesn't make any sense, right? I mean, all I'm doing is I'm trying to use the shadow features or decoy features, which are not available, which are not task relevant. And then I'm still able to say that, well, you give me the description of the image, I can tell you if that is a fake image or a real image. In real world, it doesn't make any sense, right? So, but this is the observation that we make from the algorithms. So, which means that there is still a lot of scope to understand all these factors and then disentangle them to create better methods. And then what happens if I'm trying to put things together, right? So let's say I take this 31 features, 31 annotations that we have, and then I learn this SVM classifier, learn this random forest classifier. I get an accuracy of 70%, 66%, and then I only take the top 5 features and the most informative features in that annotations, and even with them, I can get 63%. Now, 63% is not a lot, but 63% is already very good performance to say that I can identify some image, identify any image as a fake image just based on description 60% of the time. Here's some idea. Okay, so the idea here is that to try to understand and disentangle what is causing these bias factors. Okay, good. Now let's go a bit further. Okay, maybe I should stop at this point and then ask if there are any questions. No questions? But everybody is on board with me to understand that there is a bias in the data set level, there is a bias at the algorithm level, right? Okay, good. So now I know that it's a bit too much of information to talk about all those things. So what I would want to do in the next couple of slides is to give you some suggested directions so that you can go back and then maybe some of you might be interested in picking up this direction and then work on this. I stole a cartoon from this XKCD, which talks about two factors, correlation and causation. Maybe you might want to take a look at this for a moment and then we can continue. Okay, so what is the fundamental problem in everything that we discussed so far? In all the works that we discussed so far, we were discussing about correlations, right? So we never understood what is the causation. There is two different principles, right? So I get a database, I just look at what is the correlation between all these different factors, and then I run a bunch of algorithms, and then I say these are my results, and I make my observation based on that. But that necessarily is not the only thing that we have to look at, right? We have to also look at what is the causation. Specifically in the case of medical domain, if you're going to use your generative AI, if you're going to use it for treatment purposes, then you should understand both the aspects of correlation and causality. Gives you an idea? So this is very underexplored field. So the second part is something that you might want to consider for future works. And the why do I say that? It's said because our analysis is best under the circumstances. So with all the knowledge that I have about the data set, I can make such statements. And for everything that I know, these statements might not hold true tomorrow morning. Because if some new data set comes, then I have to redo all this analysis. So take this into consideration all the time. Try to make your data sets balanced for all different attributes, whatever the study that you're doing, right? I know it's a very tough ask. It's never possible to create such ideal data sets, but at least try to come closer to what we want. And then there is this other thing, right? So what can we do for avoiding all these kind of biases in generative AI? Can we do something about that? So here is some initial ideas which were provided. There the idea is that if you have this training strategies for GAN, in that case they're talking about this sensitive attribute, right? So if race is a sensitive attribute, whether it's black or white, now the goal here is that how to predict the income given a particular race. And in this case, they use this example to show how we can mitigate them. Now, you can see that by inducing that factor already into the training, you can balance the accuracy. You can have better accuracy in prediction. Right? You can see that here, right? So the bias factor, the race factor, and then what is the accuracy? So how much is it varying across different iterations? And look at that very closely. So this comes down to again the probabilistic modeling, right? P of A given B, P of X given Y. From the day one lectures, right? We started with Bayesian theorem, Bayes theorem, and Bayes theorem we kind of formulated it that way, which is exactly what we are using it, right? And the second thing is any ideas that you could connect it to the GAN, the other approach that we spoke about. You recall the idea of conditional GAN, not only just training the GAN, but also introducing the labels of the class. So class conditioning, so which is exactly what we can do, right? So by using such strategies, we can mitigate the bias to a certain degree. Not completely. I'm not sure if we can do it, but at least to certain degree, we can mitigate it. Okay.
Make predictions for the labels, not for the whole data set.
Not for the whole data set. Yeah. By inducing the labels, what you're trying to say is that okay, this particular label is represented in such kind of condition. so the machine is better informed. Yes, it's categorized so that the machine becomes more informed. Yeah. Okay. Other questions? Any questions so far? No, and then I'll more or less end this slide by end this part by talking about this other topic, which is called as Simpson's paradox. So it's like the where they talk about the interpretation of different contingency tables, right? Now, why is it a Simpson's paradox here? So if I simply eliminated this color in this dot, then I could create two different diction boundaries, right? I could create it this way, or I could also create it this way, right? Depending on the way you are looking at the data, the results will be very, very different. So if you have some time, try to read this very old paper from, I think it's 1951. So where they talk about this paradox, and this paradox holds even today very well, right? Specifically when we are talking about these aspects of ethical use of this generative AI in a framework that is more constrained to the legal frameworks, these concepts become very relevant. Okay, that is all I had for this topic. I deliberately did not want to touch all the legal framework because the legal frameworks might vary from country to country. So it's very important that we have the experts that can actually talk about those things rather than me being a technical person. I can't really interpret that particular part of the law. So that said, I would stop the this part of the lecture here. So if we have more time or if there is any topic that you would want to discuss in detail, maybe we can think about that. If not, I was told that you have some interesting quiz happening soon. Any questions for any topic that you had been discussing so far, not necessarily on this area, right? So I'll not share the slides from yesterday and day before yesterday. So I will share all the PDF today and then day wise I'll put it them and then you can share them. You can access them.
Okay, so we'll start with in couple of minutes. This time we'll give small gifts to top 5 winners, not top 3. And previous winners are also eligible, but just one of them.
No, I don't mind even if
And from MNIT also only one is allowed.
Okay, so then before everybody leaves from here, I